An electrical circuit of resistance R, R1, R2 and voltage sources E1 and E2 as shown in figure. The correct equation for the loop E, B, C, D, E. So, we are given the loop E, B, C, D, E. Now, for this loop E, B, C, D, E, we have to write down the correct equation. Now, this is based on Kirchhoff's voltage law. Now, according to Kirchhoff's voltage law, let us trace the circuit from point E to B. Along the path AB, we are having a source of EMF E1. So, I will write a source of EMF E1 and whether it is positive or negative. See here, while tracing the circuit, we are moving from E to B. Means within the cell, we are moving from negative terminal towards positive terminal, and whenever we are moving from negative terminal towards the positive terminal within the cell, then the EMF of that cell will be taken as positive. Will be taken as what? Positive. Now look at the junction point B. Here I1 is current produced by source of EMF E1. I2 is current produced by source of EMF E2. So at the junction point B, we are having two incoming current. One is current I1 and other is current I2. Then according to Kirchhoff's current law, the sum of incoming current is equal to outgoing current. Here we are having only one outgoing branch and incoming currents are I1 and I2. So what is the outgoing current? It is I1 plus I2. So this I1 plus I2 current will flow through that external resistance capital R. External resistance what? Capital R. So for the loop E, B, C, D, E, we had first moved from E to B and we had written the EMF of cell E1 with positive sign because within the cell we are moving from negative towards positive. Now between B and C, no source of EMF, no resistance, leave it. Now we have to trace the circuit from C to D. While tracing the circuit from C to D through the resistance R, current I1 plus I2 is flowing in same direction, and whenever current flows through the given resistance in a direction same as that of direction in which we are tracing the circuit, then potential difference across that branch, which is I1 plus I2 into resistance R, that potential difference, it is taken with what? Negative sign. It is taken with what? Negative sign. See this I1 plus I2 current, it will reaches at junction point E. Out of I1 plus I2, current I1 will have to reach the negative terminal of battery, while remaining current I2, it has to reach to the negative terminal of battery E2. So between C and D, we are having a resistance R through which current I1 plus I2 is flowing, So the potential difference across C and D, it is I1 plus I2 into R, and sign here it is negative because current is flowing in same direction. Again between D and E, no resistance, leave it. From E to B, we are having a resistance R1, and what is the current flowing through it? It is I1 into R1. So potential difference across this internal resistance small r1, it is I1 R1. Again what you can say, current is flowing in a direction same as that of direction in which we are tracing the circuit. So this potential difference, it is taken with what? Negative sign. This potential difference, it is taken with what? Negative sign, and that is equal to 0. That is equal to 0. So remember that whenever we are tracing any closed loop, EMF of that cell is taken as positive, in which we are tracing the circuit from negative terminal towards positive terminal within the cell, whereas potential difference across that branch is taken as negative, through which current is flowing in a direction same as that of direction in which we are tracing the circuit. So we had the equation for the loop E, B, C, D, E is E1 minus of I1 plus I2 into capital R minus of I1 into R1 is equal to 0. So which option is correct? I think that option B, E1 minus I1 plus I2 into R minus I1 R1 is equal to 0 is correct option.